We'd now like to discuss the setup or configuration of the SUPERtrol-I. We'll be going into the menus and using both the Easy Setup feature and the regular menus. We'd like you to follow along in the user manual. You'll notice in the back of the user manual on page 52 there's a menu guide. This shows the basic organization of the menus. The place for the starting point where it says Start Here is what will begin once you've entered your password and actually entered into the menu mode or setup mode. The large blocks indicate the major submenu groups. These are accessed by pushing the up or down arrow key once you're in the menus. To travel to the right to the individual detailed menus, you press the Enter key. The menu key also acts as an escape. Once you're in a detailed menu and wish to leave, pressing the menu key will bring you up to the final selection where you can choose the operating mode of the instrument. These will become more apparent as you actually pass through the configuration. So let's begin now. To begin accessing the setup mode, press the menu key. There'll be a location where you can enter a password. I'm going to attempt a valid password and also an invalid password. Let's do the invalid password first. You'll notice you get a message saying invalid password. Let's try it now with a valid password. You'll notice now that it offers you a selection where you can either return to the run mode, go to the setup mode, or go to a test mode. Pressing a key under the selection causes it to flash. We're going to be going into the setup mode. Pressing Enter actually begins that. You'll notice that the first menu is called Select Easy Setup. For many users, this is the only sequence you'll need to use. Let's try that one first. Pressing Enter indicates you wish to begin that sequence. Here, there's a warning message telling you that this changes the complete setup of the instrument. Is this what you want to do? We're going to say yes by pressing a selection underneath that item, then pressing Enter. It will ask you, how do you want to use this instrument? Are you going to be using it as a basic rate totalizer or a batcher? Each selection that you make has an effect on the menus that follow. So let's configure the instrument as a basic rate totalizer. Once you have the selection flashing, press Enter. It'll now offer you a selection on whether you wish to observe the rate in units per minute, per hour, per day, or per second. Let's use minutes. It'll now offer you a selection for the number of decimal places you wish to see on the rate display. Many users, indicating in gallons per minute, for example, may wish to either read in whole gallons per minute or perhaps down to 1/10 gallons per minute. A selection of 1 indicates you wish to see one place beyond the decimal, and we're going to use that selection. There is now a location where you can change the units of measure that will appear for both the rate display and the total. Let's take a look at what's involved in changing this text string from gallons to liters as an example. Pressing Clear causes the first digit to change. We can then get the L for liters in the first digit. Pressing Enter moves the selection over. Let's go back to gallons. Since that's the measure we're going to try, and we're going to go back and use gallons. The totalizer decimal places can also be configured on the number of digits that you wish to see. In this case, I'm going to choose to read in whole gallons, so I'm going to leave the number of decimal positions as 0. There is now a selection for the K-factor type that's going to be used. The K-factor of a flow meter is usually provided in documentation by the company. This will normally be on a sheet of paper, maybe stamped on the meter, or maybe on a removable tag. Let's pretend in this application that we want to use a meter that has a published K-factor of 100 pulses per gallon. If a meter manufacturer gives only a single value for the average K-factor, sometimes called the mean K-factor, you would be using the selection called average as to the type. If the meter is nonlinear, you may wish to use the linearization table, which will require you to enter in additional point pairs of frequency and K-factor. In this application, we're going to use the average K-factor. There is now a location where it wants you to enter in that numerical value. To enter this number, we're going to be going clear, the number we wish to enter, which would be 100, followed by an enter button. Let's go through that sequence. The unit has now stored that K-factor. Another attribute of the flow meter is the maximum flow rate that meter is capable of measuring accurately, and this is often used, or a value near that value, in setting up the analog output. In our case, if we wanted to change the capacity of the analog output, or the range of the analog output, to match the capacity of the flow meter, we can do that again by clear the number enter. I'm going to assume a 2-inch meter with a maximum capacity of 200 gallons a minute. To change that number, we'll hit clear, 200, followed by enter. That would normally complete the easy setup of the instrument, and the instrument would be ready for use. Now, you may be aware that the instrument did not ask us about the type of sensor being used, its output signal to be expected, and so on. The easy setup is normally used when there's a voltage pulse being applied to the instrument from a flow meter. If you have other signal types, such as contact closure or magnetic pickup, additional setup would be required, and there you would need to use the actual setup menus of the instrument. Looking at your configuration sheet, you'll notice that there's a complete menu group called Setup Flow Input. This will have a variety of parameters that can be set based on the actual signal you have coming from your flow meter. If you have questions about this, feel free to contact Kessler-Ellis products. Let's pretend in this application we're going to be using this with a magnetic pickup. We'll have to go into the menus to the flow input group and change the trigger level to match what the particular flow meter would be providing. To do this, we'll hit Menu, enter our password, and go into the Setup menu again. At this point, we do not wish to do an easy setup again. Rather, we wish to go to the menu called Flow Input Group. Here is the Setup Flow Input Group submenu. By pressing Enter, it's going to offer us a series of approximately 10 menus. Some of these we may need to change, others we will not. The first one, where it lists the excitation voltage, defines the voltage that will be available to you on terminal 1 in the back. Several selections are offered: 5, 12, and 24 volts. We're going to leave it at the 12 volt setting. Next, there's a question about the pulse input type. The channel A selection means that there's only going to be a flow input signal brought in on input 2. The channel A equals B selection indicates that there's 2 signals being brought into the unit for missing pulse detection. The quad times 1 and quad times 2 are the other selections. In most applications, you're going to be using the channel A. Next, there's a selection for the pulse trigger level to use. On our example of a 2-inch turbine flow meter, a selection of 100 millivolts or 10 millivolts would be considered suitable selections. The 10 millivolt selection would be used to obtain the maximum range from the flow meter. The 100 millivolt would be selected for noisier applications where the signal from noise pickup may be greater than 10 millivolts during periods of no flow. I'm going to choose the 100 millivolt selection here. Next, you'll notice there's a menu that offers you several different low-pass filters. These are basically noise rejection settings to eliminate the possibility of picking up higher frequencies than what might be actually output by the flow meter. The 3 kilohertz setting is commonly used on turbine flow meters. The next menu allows you to choose a terminating resistor. These are built within the unit and are activated through the menus. Selections of pull-up, pull-down, and none are offered. For a turbine flow meter, either pull-down or none can be used. I'm going to use the pull-down selection. Next, there's a menu offered for window settings. This is the maximum period of time that the indicator will wait for a pulse to come in before assuming that the flow rate is 0. We're going to use the 1-second selection since the frequencies from flow meters of the turbine type are normally between 10 Hz and 1000 Hz. Waiting 1 second is adequate to determine there is no flow. You may remember the selection of K-factor type from the easy setup, and we're going to leave those selections where they were. Similarly, the K-factor selection is the number we entered previously. There are warning alarms that can be signaled to the operator when his flow meter is being used out of range. In the case of a 2-inch meter of the turbine type, a range of perhaps 10 to 220 gallons a minute would be considered satisfactory. We're going to leave a setting of 0 in this case, since the application is assumed to have periods of no flow where we are not trying to create a nuisance alarm warning to the operator. In the case of the high flow rate alarm, we're going to change this number to enable no warnings unless the flow rate exceeds 220 gallons a minute. Again, to change a message, we just will hit clear, enter the new value of 220, and press enter. At this point, the entry selections for the flow input have been completed. To escape out of the menu mode, you press menu to return to the selection that says Run, Setup, and Test, and choose the Run mode. Pressing Enter will return you to the Run mode. The unit is now fully configured for the basic application with a turbine flow meter measuring in gallons per minute and gallons for use with a magnetic pickup. For additional menu selections on the other outputs, please refer to the user manual and make changes as needed.